A good day. Welcome to another lesson on mathematics. Today we are going to discuss logarithms, zimsec exam questions on logarithms. But before we start answering the questions, we need to discuss some laws of logarithms that we are going to be using. We need to discuss some laws of logarithms. And remember, when logarithms, there is a big connection with logarithms and indices. There is a big connection between logarithms and indices. So if you don't understand indices, most of the questions here, they are going to be difficult for you to answer. You need to understand indices before you move on to logarithms. Now, let's discuss some three laws that we are going to use for today's lesson. Law number one, it says log of x plus log of y is equal to log of x, y. When there's no sign in between, you know you are multiplying. So we are saying log of x plus log of y is the same as log bracket x times y, not equal to log of x times log of x times log of y. There's a common mistake here. This is wrong. We are saying log, we want to write this as a single log. Can you see? We have got log and log here, but we are writing it as a single log. So we are moving from two logs here and writing it as a single log. Very important. We have got two logs here. The law, we want to write it as a single log. So when you are adding, what do? You multiply. Then law number two, log of x minus log of y. The same thing, we want to write it as a single log. Is the same as log of x upon y, not log of x divided by log of y. Not the same. We are writing it as a single log. So when you are minusing, you divide the numbers. You divide. Then law number three, n log of x. This can be written as log of x to the power of n. Remember these laws, I can move from this side going to that side. If I'm given this side, I can move to that side. The same thing here, if I am given this side, I can move to that side. If I'm given this side, I can move to that side. This is how the laws work. These are laws. So we are saying these are the three basic laws of logarithms. Besides these three, you need to know these ones also. Log of 1, log of 100, log of, I left log of 10 here, log of 10, log of 1000, log of 10,000. What is the answers of this? Log of 1 is equals to 0. Log of 10 is equals to 1. Log of 100 is equals to 2. Log of 1000 is equals to 3. Log of 10,000 is equals to 4. Here we are just counting the number of zeros. How many zeros do I have here? There is no 0. So log of 1 is 0. Log of 10 is 1. Log of 100 is 2 because I've got 2 zeros. Log of 1000 is 3 because I've got 3 zeros. You need to know these laws by, the log of these special logs by heart, because we are going to be using them somewhere. So we are saying now with these three laws and these easy ones, they are easy to remember. These ones, they are easy to remember. Let's start answering our question. Now, given that log of x, this was from June 2020, which was question 1. Remember, logarithms normally they come in paper 1. Log of x is equals to 6 and log of y is equals to minus 2. Evaluate log of x, y. So in other words, you are given log of x, y. You are multiplying these two now. You are multiplying these two numbers. So I can move. This can be written as this. So this is the same as log of x plus log of y. Can you see? This is the same as log of x plus log of y, because that's what the law is saying. When you are multiplying with a single log, you can separate it in this way because that is the law. Now, what is log of x? You are given that log of x is equals to 6. So I go and substitute 6 here because log of x is the same as 6. That's what they're saying. Then what is log of y? Log of y is the same, but there's a plus here. Plus is the same as minus 2. So if I add these two, I'll get a 4. I'm done with the first one. Moving on to the second one, you are required to evaluate log of 1 upon root of x. This now, you are given 1 upon, you are dividing, you are given this, you are dividing. So we can write it as this. So this is the same as log of 1 minus log of root of x. This is the same as log of 1 minus log root of x. But now this, we want to create a power. You know you can change from radical to exponent. We know you can change. We know there is a law which say a to the power of 1 over n is the same as the nth root of a. We discussed this when we were talking about indices. If you don't know this, go to the lesson that I did on indices. We discussed this. So this can be written as log of 1 minus log of x to the power of half. Log of x to the power of half. Now I have got this one. This can be written as this, which is the same as log of 1 minus half log of x, which can be written of this one. But log of 1 is what? It's 0. So I go and substitute 0 minus half. But what is your log of x? In this case, log of x you are given is 6. So half multiplied by 6, which is the same as 0 minus half multiplied by 6, you get 3. So the answer is equals to minus 3. The answer is equals to minus 3. Laws, you are just using laws. Now, let's go on to the next question. The next question, it says, evaluate. I'm going to write it here. You are required to evaluate. In this case, you are not given that log of what is equals to what. You are just required to evaluate log of 16 divided by log of 4. Now, I can't use this law. I can't use this law. There is nothing that say when you are dividing the laws. Can you see there is no law of that? So what are we going to do here? This can be written as log of 16 upon log of 4. We know this. This can be written as log of 16 upon log of 4. There are two ways in which you can evaluate this. The one way of doing it, I find it easy to do it like this. This 16 can be written as 4 squared. Why am I using 4? Because I want to use this law so that I can use this law. So this is the same as log 4 squared upon log of 4, which is the same as 2 log of 4 upon log of 4. The main reason why I was creating this 4, so that this and this can cancel. The same when you are doing 5x divided by 5. This 5 can be cancelled. So this, not only for log of 4 can cancel with log of 4. That was the reason why I was creating a 4 here. That was the reason why I was creating a 4. Therefore, the answer is equals to 2. There are different ways of solving this one. There are different ways of solving that one. Moving on to the next one. You are given B, log of 5 minus log of 0.5. Let's check our laws. This is the law. This can be written as log of 5 upon 0.5. This can be written as log of 5 upon 0.5. Then you go and divide 5 divided by 0.5. Remember, this is paper 2 and you don't have a calculator by this stage, but I think everyone knows how to divide these numbers. So this will be the same as log of 10. If you divide 5 divided by 0.5, you get 10. Now, what is log of 10? Log of 10 is 1. Therefore, the answer is 1. Log of 10 is equals to 1. Therefore, the answer is 1. Now, moving on to the next question. Given that this is similar to number 1, given that log of 6 is equals to this one and log of 5 is equals to this one, evaluate the following log of 30. But you can see log of 30, we have got a 6 and we have got a 5. There is a way of writing a 6 and a 5 to get 30. If I say 6 multiplied by 5, I get 30. So this is the same as log of 5 times 6 or 6 times 5. It's the same as that. This is because this, I didn't change anything. 5 times 6, you get what? You get 30. After that, you go and use the log now. When you are multiplying, yeah, you can separate. This is the same as log of x plus log of y. So this is the same now as log of 5 plus log of 6. Then I go and add these two numbers. Log of 5 is 0.6990 plus log of 6 is 0.7781, which gives you, if I add these two numbers, I get 1.4771. Then moving on, this will be my last question. Then tomorrow we are going to have part 2. This one, for you to do this one, you need to understand indices. You need to know how to change from indices to logarithms and from logarithm back to indices, which we are going to discuss tomorrow. Now, to do this one, you are given 1,200 million. You required to evaluate 1,200 million. But this one, 12, I'm dealing with this 12 that is in front. I know if I say 6 divided by 5. This logarithms is one of the tricky questions, especially this one. I know if I say 6 divided by 5, I get 1.2. I'm creating this 1, 2 that is in front using a 6 and a 5. The same thing that I did here, I was creating a 30 using a 6 and a 5. We know 6 times 5, I get 30. But I want to create something to do with 1, 2. It can be 12, it can be 1.2, or it can be whatever you want to do. But we must have 1 and 2. But we know 6 divided by 5, we get 1.2. Now, to come back to this number, I need to multiply it by what? I need to multiply it by 1 million. In other words, I am saying 1.2 multiplied by 1 million, I get 1,200 million. Now, using our laws of logarithms now, this 1,200 can be written as log of 6 upon 5 times 1 million. Log of 1,200 million can be written as log of 6 upon 5 times 1 million, because you can see if I say 6 upon 5 or 6 divided by 5, I get 1.2. But if I say 1.2 multiplied by 1 million, I get this number. Now, let's use the law. When you are dividing, you subtract. So this is the same as log of 6 minus log of 5, because here we are dividing and here we are multiplying, plus log of 1 million. Now from there you just need to go and substitute the values that you are given. Log of 6 is this one, so 0.6990 0.7781 minus log of 5 is this one, 0.6990 plus log of 1 million, it's 6 because I've got how many zeros? 6 zeros. Then now you just need to simplify. This is a plus, not a times. Then now you just need to simplify this. If you simplify this, you are getting 5.0791. This one was a tricky one. This one was the only one that was tricky. But what are we doing here? I need to create a 1, 2 in front. But the way of getting 1, 2 from 5 and 6, you are going to say 6 divided by 5, you get 1.2. After I get 1.2, I need to multiply by 1 million to come back to the number that I am given. Then after that, then you start using the laws. Thank you for watching and enjoy your day.